Hello everyone, welcome back. Today's lesson, I'm going to show you how to find the y-intercept and of an equation, actually the slope and the y-intercept of an equation. So the first thing I want to talk about is that when you have a linear equation that's in this form, y equals mx plus b, remember that your m is your slope, and then your b is your y-intercept. And that's always going to be in coordinate form. So 0 comma b is your y-intercept. So let's look at the following example of an equation, okay? And let's say you had 1/4 y minus x equals 2. The problem with this equation is that it's not in the slope-intercept form. So remember that this equation that I gave you is your slope-intercept form, because m is your slope, b is your y-intercept. That's why they call it slope-intercept form. This equation, however, is not in that form. It's actually in standard form. Believe it or not, this is in standard form, okay? And standard form, it's going to look just like this. It's going to be something like this, where you have your x and your y's on both sides of the equation. Doesn't matter really the order, but your x and your y's are on both sides, and that's generally going to equal a constant. And you can clearly see that 1/4 y minus x. You notice the y term and the x term are on the same side, so that's considered a standard form. So we're going to convert that standard form to slope-intercept form, okay? And let me just show you, that just takes a little algebra. It's basically solving for y, getting the y by itself. So it's kind of like rearranging the equation using some basic algebra skills. So we're going to apply those skills right now, okay? So the first thing I'm going to do is I'm going to, remember, we want to get y by itself. So since y is on the left, I'm just going to keep it on the left. And I'm going to go ahead and move my x term to the right. And as you can see that these will cancel, then you're just left with 1/4 y equals, now instead of writing 2 plus x, I'm just going to write x plus 2. Algebraically, those are different terms, so I'm not going to be able to combine an x and a number, a variable and a numerical. So I just write it horizontally. And then you notice that the 1/4 y, we can go ahead and multiply it by its denominator, all right, on both sides, okay? And when we do that, then we can go ahead and cancel the 4's, and then you're just left with 1y, or just y. This is going to be written as 4, and then in parentheses, x plus 2. It's not 2 times 4. It's 4 times the whole polynomial of x plus 2. We have to take that, and we have to distribute the 4 over the x and the 2, over the parentheses, I mean. Okay? So when we do that, then you're just left with y equals 4x plus 8. And now you notice that, let me just rewrite it over here because I'll have a little more room. Okay? You notice that it almost looks like this form. Can you guys see that? Y equals mx plus b. So you can clearly see that the m is going to be your 4, your slope of 4, and this is your y-intercept. When you write it in coordinate form, it's going to be x comma y, so we should write it as 0 comma 8. Okay, your 8 is the y coordinate, and that's what it would look like. So it's just some basic algebra of going from standard slope-intercept form, standard form to slope-intercept form. Okay, so just wanted to give you a brief little lesson on that. Okay, the other thing is that you can have, we want to be able to identify we want to identify parallel lines and perpendicular lines, all right? So when we identify parallel and perpendicular lines, just keep in mind that you have, three situations, okay? And this is what's going to happen in those situations. You're going to have two lines, okay? So if you have parallel lines, then they should look like this. Okay, parallel. Parallel lines will have the same slope. Okay? Because they're not touching each other. Whatever one line is doing, it's going to copy the other line. It's going to be parallel. That means they're never going to intercept each other because they have the same exact slope. So they're never ever going to come together. Okay? The other situation is that you can have perpendicular lines and when that happens, it's going to form a 90-degree angle. A perfectly 90-degree angle. Okay? So that's called perpendicular lines. And perpendicular lines, the slope of the other line is going to have a negative reciprocal. So it's going to be like this. Okay? And that's considered a negative reciprocal. And I'll explain that when we do examples on the next slide. Okay? And then, of course, you can have situations where you can have two lines, okay, that will eventually intercept each other. So you'll have a point of interception, okay? And that's going to be neither, obviously, because they're neither perpendicular nor parallel. Okay, so they're neither parallel or perpendicular. That is the symbol. So perpendicular, we use this symbol, okay, the upside down T. Parallel is that. All right? Okay, so now that we have a little bit of a basis of what perpendicular parallel lines and whether they're neither, we can go ahead and identify them, okay? So a typical problem would be something like this. Okay, determine if the lines are parallel, perpendicular, or neither. So we'll designate line 1 as y equals minus 3x plus 7. And then line 2, okay, we will call that y equals 1/3 x minus 4. All right, so those are your two lines that we're going to have. Notice that both equations are already in the slope-intercept form. Okay, so they're both into the slope-intercept form. Y equals mx plus b, and so is this one, mx plus b. And we should be able to determine what the slope is and what the y-intercepts are. Now, when we compare lines, we're interested in the slope, okay? Not necessarily the y-intercept. And when we look at the slope of both lines, you notice that the line 1 has a slope of -3, the other one has 1/3. And when you do this, this is very important, okay? So we're going to label this as M1, and we said that was -3. That was the slope for this line. This slope, M2, is going to be 1/3. And we need to know, now they're not the same slope, so parallel is out of the question. They both have to be -3 or both have to be 1/3 in order to be parallel. That's not the case here, so we can eliminate the parallel. The only other options we have perpendicular or neither. So we need to see if these are perpendicular before we say neither, okay? So when you have a slope of M1, okay, and you want to find the perpendicular slope, well, if M1 is equal to -3, then M2 must be the negative reciprocal in order for it to be perpendicular. Well, what is the reciprocal of -3? It's going to be 1/-3. All right, so that's called the reciprocal if you just take the reciprocal, right? But to take it a step further, right, and you want to actually find the negative reciprocal, we not only have to flip it, which we did, but we have to change the opposite sign. So the opposite sign of negative is plus. So therefore, this slope is perpendicular, okay? So the lines are perpendicular to each other, okay? So we always need to do the perpendicular test. Parallel, super easy to spot. If both slopes are identical sign, identical number, then our job is done. If we're not sure, I mean, if they're not the same, in this case, they're clearly not the same, we need to see if it's the negative reciprocal. So you take -3, and when you do that, -3 is really written over 1. So when you flip it, it now becomes 1/-3. And then we change the sign. The opposite of negative is 1/3. And therefore, this is perpendicular, so it checks. And then that's a perpendicular. These two lines are perpendicular to each other. So if you graph them, they're going to form a 90-degree angle. We don't necessarily have to graph them because that's not what the question's asking. Okay, we can do it without that graphing. We can just identify the slopes. All right. Let's do another example. Okay. And let's say you had line 1. Line 1. Line 1 is going to be y equals 2x plus 1/2. Line 2 is going to be -6x plus 3y equals 15. Okay, and now you notice that the first line 1, is in mx plus b form, you know, the slope-intercept form. Line 2 is in standard form. So in order to make that comparison, okay, this one is already in the mx plus b form. So in order for me to compare the equations, I'm going to get this equation into standard mx plus b form. So what I'm going to do is I'm going to solve for y for line 2. I'm going to make line 2 look like mx plus b. All right? So here's what I'm going to do. All right. So, okay, so here we go. God, why does that keep popping up? All right, so I'm going to add 6x to both sides. Okay, and I want to do that so this cancels, and then I'm just left with 3y equals 6x plus 15. Again, I want to write the x term first, followed by the number. Now we can't add 15 plus 6x because they're different terms, right? One has an x variable, one doesn't. So you just write it as that horizontally. And now we're going to divide everything by 3 so that the coefficient of 3 cancels. Then we're left with y equals 3 goes into 6, 2, so that's 2x. 15 divided by 3, okay, is 5. All right, and now this one looks like y equals mx plus b. Okay, so now you can compare the slopes. You notice that both slopes, okay, are identical, 2 and 2. So both lines have a slope equaling 2. So therefore, both lines are parallel. Okay, they're parallel to each other. All right, so if you have an equation that's not in the mx plus b form, go ahead and do a little algebra, manipulate it, get it into that form. And that way you can clearly see the two slopes, you compare the two slopes, and then you can make a decision on whether they're parallel or perpendicular or neither. Okay, so that was a good example. All right, so let's do one final one. All right, and we're going to have negative 4x. Let me go ahead and identify that as line 1 is going to be designated as minus 4x plus y equals negative 2. Line 2 is equal to minus x plus 4y equals 3. Now both of them are in standard form. They're not in the mx plus b form. Okay, so we're going to have to solve both of these for y. So we're going to do a little algebra. Okay, we're going to bring the 4x over to this side so that it cancels, and then you're just left with y equals 4x minus 2. All right, that was pretty easy to do. Okay, that's one of them. The other equation is we're going to add x to both sides. Again, we want these to cancel, and then you're just left with 4y equals x plus 3. Then you divide everything by 4, and then the 4's will cancel, and then you're just left with y equals, again, x over 4 is the same thing as saying 1/4 x plus 3 over 4. You can write the x on top. You can write x over 4 or 1 over 4 because the coefficient of x, there's an invisible 1 there. Okay, so you look at the slopes. Okay, you notice that m1 is 4, and then m2 down here is 1 over 4. Now 1 over 4 is the reciprocal, but it's not the negative reciprocal. If it were negative 1/4, then that would be the negative reciprocal, and then we can say they're perpendicular. But since it doesn't have that negative sign, then the lines are neither. Okay, so that is that. Okay, and there you have it. Those are your 3 possible scenarios that you're going to get for those lines. Thank you so much for watching, and I hope this was a very helpful video.